All right, so we're going to take what we just kind of looked at on that circle and look at a specific circumstance for the screamer ride. So we have LaRasha. When she got stopped on the screamer, she was sitting 27 feet away from the center support pole. Now, we know that the radius of our screamer ride is 100 feet. So that means she's probably maybe somewhere in this vicinity, right? So she's 27 feet away, which means we have to figure out what her angle of rotation was. Now we know from experience that there's going to be 4 different possible angles of rotation here. So I'm just going to draw all 4 of those in, and we can start to sort of think about how we would find those. So we know that this length is 27 feet. Now, we just talked about how that length is directly related to the cosine value, but what you have to be careful of here is that because the hypotenuse is 100 and not 1, you've got to be a little bit more careful with this, right? Theta's here. So write an equation, just like we did with our triangles last week. So cosine of theta equals 27 over 100. Now you can go ahead and type that into your calculator. If you tried to do this without thinking about the fact that your circle has a radius of 100, you probably got an error message if you tried to type that into your calculator. So we're going to get theta, let's say, is about 74 degrees, okay? Now we can sort of visually, that makes sense, right? This angle is going to be 74 degrees. But then you actually have 3 other possibilities. And this goes back to what we talked about in the previous video as well, because that 74 degrees is how far we are from the x-axis. So I would need to go backwards from 180, 74 degrees. So I would get 106 degrees for the angle in the second quadrant, go forward from 180, 75 degrees, or 74 degrees, and I'm going to get 254, and then go backwards from 360, 74 degrees, and we'll get 286 degrees. So she actually has 4 different places on the Ferris wheel that she might have been stopped.